Okay, so in last lecture we have calculated the equations for the space resistance and surface resistance. So what is the equation for the surface resistance? That is 1 minus epsilon divided by epsilon into area. So by using this equation we have to calculate the surface resistance. Suppose we have two plates and one plate is radiating energy to the another plate and another plate is radiating energy to the first plate. So at that time whatever the surfaces are there, in that surface one resistance is created and that resistance is nothing but surface resistance. And how to calculate this surface resistance, there is a equation for that, and we have derived that equation, that is 1 minus epsilon divided by epsilon into a. So by using this equation we have to calculate the surface resistance. Okay, this is about the surface resistance. After that we have calculated the equation for the space resistance, means if two plates are there and in that two plates there is a space. So due to this space what will happen, some resistance will be created. And how to calculate this space resistance, there is a one equation for that, that is 1 upon a1 into f12, that is one a1 is nothing but surface area of that plate and f122 is nothing but shape factor. So by using this equation we have to calculate the space resistance. We have to calculate the space resistance. So what is the meaning of this? Suppose there are two plates and outside surface of these two plates is insulated. Okay, so heat transfer takes place from one plate to the another plate. In between these two plates there is a space. So for that particular geometry there are total three resistances. Okay, two surface resistances and one space resistance is there. So whatever the equation we have written in the form of resistance, so we have to take the all resistances at the denominator. So how to calculate the net energy, that is Q122 is equal to EB1 minus EB2 divided by sum of all resistances. So R surface 1 plus R space plus R surface 2. So in that way we have to write down the equation, and by using that equation we have to calculate the net energy. We have to calculate the net energy. Okay. So we get the final equation as a Q12 is equal to sigma into bracket T1 raised to 4 minus T2 raised to 4 divided by 1 minus epsilon A divided by epsilon 1 A1 plus 1 upon A1 F12 plus 1 minus epsilon 2 divided by epsilon 2 A2. So this is the final equation. So by using that equation we have written the one factor, that is FG12, that is gray body factor. And what is the gray body factor? That is 1 upon 1 divided by 1 minus epsilon A divided by epsilon A plus 1 upon F12 plus 1 minus epsilon 2 divided by epsilon 2 A1 by A2. So this is the gray body factor. So after that we have considering the three cases. Case 1, that is when the radiating bodies are infinite and parallel planes, at that time what will happen, A1 is equal to A2 and shape factor is equal to 1. So by putting this value we get the gray body factor as a 1 upon epsilon 1 plus 1 upon epsilon 2 minus 1. Okay, in the case number 2 we have to considering the radiating bodies are concentric cylinders or spheres. So for that case shape factor is 1. So by putting that value we get the gray body factor as a 1 divided by 1 minus epsilon 1 divided by epsilon 1 plus 1 plus 1 minus epsilon 2 divided by epsilon 2 A1 by A2. So in case of concentric cylinder we have to find out the value of A1 by A2, and that value is nothing but R1 by R2. And similarly we have calculated the value for the concentric spheres, then we get the value of A1 by A2 is equal to R1 square by R2 square. Okay, so this is the case number 2. Then we have discussed about the case number 3, that is when a small body lies inside a large enclosure. So at that time what are the conditions? That is shape factor is 1, then A1 by A2 we have to consider approximately 0, because A1 is so small compared to A2. So therefore we have to considering that A1 by A2 is tends to 0. So from that we get the gray body factor as a 1 upon 1 minus epsilon 1 divided by epsilon 1 plus 1. Okay, so this is the last lecture. We have derive the equations for the surface resistance, then space resistance, then what is the net heat transfer, then what is the gray body factor, and we are considering the for three cases, and for that three cases what is the value of gray body factor. So that part we have covered in the last lecture. So today now present the screen. Yes sir. Okay. So now today we have to start the next point. That is this is the last point, the last point of this unit number 3, that is radiation. And that point is nothing but radiation shields. Okay. So in the last point we have covered there are two plates and each plate is emitting the radiation to the another plate. So for that we have to considering the surface resistance, phase resistance, and by using that equation we have calculated the net heat transfer. Okay. So whatever the two plates are there, then energy exchange between that two plates is takes place. For that we have written the equation. Now in this case, what is meant by radiation shield? In certain situation it is required to reduce the overall heat transfer between two radiating surfaces. म्हणजे ज्या काही आपल्या दोन प्लेट्स आहेत त्याच्यामध्ये जे काही रेडिएशनमुळे हीट ट्रान्सफर होणार आहे, ती जर हीट ट्रान्सफर आपल्याला कमी करायची असेल, ऍट दॅट टाइम वी हॅव टू यूज दी रेडिएशन शिल्ड. समजते बघा, दोन प्लेट आहेत, दोन प्लेट मधून काय होणार आहे, एनर्जी इमिट होणार आहे इन द फॉर्म ऑफ रेडिएशन. But there are some situations are arises at that time we have to reduce the overall heat transfer between these two radiating surface. म्हणजे दोन जे काही सरफेस आहेत त्याच्यामधून जे काही रेडिएशन इमिट होणार आहेत त्याचा जर ओव्हरऑल हीट ट्रान्सफर आपल्याला जर कमी करायचं असेल ऍट दॅट टाइम वी हॅव टू यूज दी रेडिएशन शिल्ड. समजलं का बघा, रेडिएशन शिल्ड कधी यूज करणार आहे, ज्या काही आपल्या दोन प्लेट आहे त्याच्यामधला जो काही हीट ट्रान्सफर जो आहे तो कमी करायचा आहे. सो फॉर दॅट वी हॅव टू this is done by either using a material which are highly reflective. So for this we have to use the high reflective material. Okay, or by using a radiation shield between the heat exchanging surfaces. So for that we have to use this radiation shield in between these two plates. म्हणजे ज्या दोन प्लेट मधून हीट एक्सचेंज होणार आहे त्या दोन प्लेटच्या मध्ये आपण काय पुट करणार आहे, टू पुट दी रेडिएशन शिल्ड, किंवा त्याला आपण काय म्हणणार आहे, विच इज ए हाय रिफ्लेक्टिव्ह मटेरियल. वी हॅव टू पुट इन बिटवीन दॅट टू प्लेट्स. दोन प्लेटच्या मध्ये आपण काय करणार आहे, ती रेडिएशन शिल्डची प्लेट पुट करणार आहे. सो बिकॉज ऑफ दॅट व्हॉट विल हॅपन, द सरफेस रेजिस्टन्स विल बी इन्क्रीजेस. एखादी प्लेट आपण ऍड करणार आहे, ज्यावेळेला प्लेट ऍड करणार आहे, सो दॅट प्लेट हॅव्हिंग टू सरफेसेस, प्लेटला दोन सरफेस असणार आहे, एक लेफ्ट हँड सरफेस एक राईट हँड सरफेस. सो बिकॉज ऑफ दॅट रेजिस्टन्स विल बी इन्क्रीजेस. कुठला रेजिस्टन्स इन्क्रीज होणार आहे, बिकॉज ऑफ दिस सरफेस रेजिस्टन्स विल बी इन्क्रीजेस. So due to this surface resistance, what will happen? Net heat transfer will be reduces. समजते बघा, ज्यावेळेला आपण दोन प्लेटच्या मध्ये एक रेडिएशन शिल्ड पुट करणार आहे, ती रेडिएशन शिल्ड म्हणजे एक प्लेट असणार आहे हॅव्हिंग हाय रिफ्लेक्टिव्हिटी. सो दिस प्लेट हॅव्हिंग टू सरफेसेस अँड दिस टू सरफेसेस हॅव्हिंग टू surface resistances, and because of that what will happen here, heat transfer rate will be reduces. Okay, so in this way we have to reduce the heat, overall heat transfer between the two radiating surfaces. For that we have to use the radiation shield. Okay, so the radiation shield reduce the radiation heat transfer by effectively increasing the surface resistances without actually removing any heat from the overall system. जी काय ओव्हरऑल सिस्टीम आहे त्या सिस्टीम मधली हीट सेम राहणार आहे. समजतंय बघा, जी काय सिस्टीम आहे, दोन प्लेट मधली जी काही हीट एक्सचेंज होणार आहे ती सेम असणार आहे. सो नाउ व्हॉट वी हॅव डुईंग, वी हॅव टू ऍडिंग वन प्लेट इन बिटवीन दॅट टू प्लेट्स. म्हणजे त्या होल सिस्टीम मधली हीट ट्रान्सफर जी असणार आहे ती सेम असणार आहे. फक्त फरक काय होणार आहे, जी काय प्लेट आपण ऍड करणार आहे त्याच्यामुळे सरफेस रेजिस्टन्स इन्क्रीज होणार आहे. अँड बिकॉज ऑफ दॅट सरफेस रेजिस्टन्स ऍट दॅट टाइम व्हॉट विल हॅपन, हीट ट्रान्सफर रेट विल बी रिड्युसेस. पण त्या ओव्हरऑल सिस्टीम मधला हीट ट्रान्सफर काय असणार आहे, सेम असणार आहे. ओके, सो बिकॉज ऑफ दिस रेडिएशन, ओके, द रेडिएशन शिल्ड reduce the radiation heat transfer by effectively increasing the surface resistances without actually removing any heat from the overall system. म्हणजे त्या सिस्टीम मधून सिस्टीमच्या बाहेर हीट टाकली जाणार नाही, त्या सिस्टीम मध्येच काय असणार आहे, ती हीट असणार आहे. ओके, ओनली वी हॅव टू इन्क्रीजिंग दी सरफेस रेजिस्टन्स. ओके, then thin sheet of plastic coated with highly reflecting metallic films on both sides serve as a very effective radiation shield. तर कुठलं मटेरियल आपण यूज करू शकतो, रेडिएशन शिल्ड म्हणजे काय असणार आहे, रेडिएशन शिल्ड इज नथिंग बट थिन शीट्स ऑफ प्लास्टिक कोटेड विथ हायली रिफ्लेक्टिंग मेटॅलिक फिल्म्स. एक प्लास्टिकची थिन शीट आहे, थिन शीट ऑफ प्लास्टिक कोटेड विथ हायली रिफ्लेक्टिंग मेटॅलिक फिल्म. एक प्लास्टिकची शीट असणार आहे आणि त्याच्यावर काय असणार आहे, हाय रिफ्लेक्टिंग मेटॅलिक फिल्म असणार आहे. आणि ती जी फिल्म असणार आहे ती काय असणार आहे, दोन्ही साईडला असणार आहे. अँड दिस इज नथिंग बट ए इफेक्टिव्ह रॅडिएशन शिल्ड. इफेक्टिव्ह radiation shield. So what are the applications of this radiation shield? So applications of radiation shield in the measurement of the temperature of fluid by using the थर्मोमीटर. जो काय आपण थर्मोमीटरनं टेम्परेचर मेजर करतो लिक्विडचं, तर त्या थर्मोमीटरच्या वरती रॅडिएशन शिल्ड असते, म्हणजे हाय रिफ्लेक्टिव्ह मटेरियल असते. त्याच्यामुळे काय होणार आहे, तर तुमचा जो काय रॅडिएशनचा इफेक्ट असणार आहे तो काय होणार आहे, रिड्यूस होणार आहे. ओके, सो ऍप्लिकेशन्स ऑफ रॅडिएशन शिल्ड्स in the measurement of the temperature of a fluid by thermometer which is shielded to reduce the effect of radiation. म्हणजे जे काही radiation मुळे हीट ट्रान्सफर होणार आहे, जो काही इफेक्ट होणार आहे त्या टेम्परेचर मेजरमेंट वरती, तो रॅडिएशन शिल्ड मुळे काय होणार आहे, कमी होणार आहे. Okay, so for these applications we have to use the radiation shields. We have to use the radiation shields. Okay, so this is the application. समजले का बघा radiation shield? I will explain once again. In certain situation it is required to reduce the overall heat transfer between two radiating surfaces. दोन surface मधला जर आपल्याला heat transfer rate कमी करायचं असेल, at this case we have to use the radiation shield. So this is done by either using materials which are highly reflective. Highly reflective material use करू शकतो किंवा we have to युझिंग रॅडिएशन शिल्ड बिटवीन दी हीट एक्सचेंजिंग सर्फेसेस. दोन हीट एक्सचेंजिंग सर्फेसेस असणार, त्याच्यामध्ये आपण रॅडिएशन शिल्ड पुट करणार आहे. ओके, सो द रॅडिएशन शिल्ड रिड्यूस द रॅडिएशन हीट ट्रान्सफर बाय इफेक्टिव्हली इन्क्रीजिंग द सरफेस रेजिस्टन्स. ज्यावेळेला आपण एखादी प्लेट त्या दोन प्लेटच्या मध्ये पुट करणार आहे त्यावेळेला सरफेस रेजिस्टन्स इन्क्रीज होणार आहे. अँड ड्यू टू द इन्क्रीज ऑफ सरफेस रेजिस्टन्स ऑटोमॅटिकली नेट हीट ट्रान्सफर विल बी रिड्युसेस. ओके, सो thin sheet of plastic coated with the highly reflective metallic film on both sides serves as a very effective radiation shield. Very effective radiation shield. Okay, then what are the applications of the radiation shield? That is applications of radiation shield in the measurement of the temperature of a fluid by thermometer which is shielded to reduce the effects of radiation. Which is shielded to reduce the effects of radiation. Okay, so this is about the concept regarding the radiation shield. Regarding the radiation shield. Okay, next slide. Okay, so this is the case. आतापर्यंत आपण मागचं जे इक्वेशन बघितलं, in that case only two plates are there and they are exchanging energy from one surface to another surface due to the radiation. But in the radiation shield concept we have to adding one plate in between that two plates. ज्या काय आपल्या ऑलरेडी दोन प्लेट आहेत त्याच्यामध्ये आपण काय करणार आहे, वन प्लेट ऍड करणार आहे हॅव्हिंग हाय रिफ्लेक्टिव्ह मटेरियल. म्हणजे प्लॅस्टिकची प्लेट आहे आणि त्याच्यावर फिल्म आपण कोटेड केलेत, मेटॅलिक फिल्म काय असणार आहे, दोन्ही साईडला कोटेशन असणार आहे. सो दॅट इज नथिंग बट रॅडिएशन शिल्ड इन बिटवीन दी टू प्लेट्स. इन बिटवीन दी टू प्लेट्स. सो वी हॅव टू डिराइव्ह दी इक्वेशन फॉर दिस केस. आता ही जी केस आहे, आपण ऑलरेडी नुसत्या दोन प्लेट कन्सिडर करताना वी हॅव कॅल्क्युलेटेड द इक्वेशन फॉर दॅट. नाउ वी हॅव टू कन्सिडरिंग दी shield in between these two plates and for that we have to deriving the equation. समजले? नुसत्या दोन प्लेट असताना ज्यावेळेला रॅडिएशन शिल्ड नाही, मध्ये एखादी प्लेट नाही आहे, त्यावेळेचा जो काही हीट ट्रान्सफर असणार आहे त्याचं इक्वेशन ऑलरेडी आपण डिराइव्ह केलेलं आहे. नाउ इन दिस केस वी हॅव two plates and in between these two plates there is a radiation shield, and because of this radiation shield what is the effect on the equation will take place. That equation now we have to see. Okay, so last slide, earlier slide. Yes sir. So all of you written this, all of you write down this within 2 minutes. All of you write down radiation shield. We have to understood concept of the radiation shield. In short, we have to write down the radiation shield concept. We have to write down the important points from this. Okay, in certain situation it is required to reduce the overall heat transfer between two radiating surfaces. So this is done by either using material which is are highly reflective or by using radiation shields between the heat exchanging surfaces. Then the radiation shield reduce the radiation heat transfer by effectively increasing the surface resistances without actually removing any heat from the overall system. Okay, then what is the material of radiation shield? That point is given. Thin sheets of plastic coated with highly reflecting metallic films on both sides serve as very effective radiation shields. Okay, And then what are the applications of the radiation shield? Applications of radiation shield in the measurement of the temperature of a fluid by thermometer, which is shielded to reduce the effects of radiation, which is shielded to reduce the effects of radiation. Okay, so those who are remaining, take the screenshot of this, and after that we have to make that much space available in the notebook, and then we have to write down the actual derivation. So make one space for this, write up and take the screenshot of this, and afterwards you have to write down that things. Okay, so yes sir, next slide. Okay, so this is the actual diagram. So for this diagram we have to calculate the net heat transfer. So whatever the heat transfer takes place from plate 1 to 3, then what is the amount of heat transfer between 3 to 2, and actually heat transfer takes place between 1 to 2. Actually in this diagram, if we have to putting the radiation shield, so in the system itself total heat is same. जी काही सिस्टीम आहे त्याच्यामधली हीट काही चेंज होणार नाही. म्हणजे 1 to 3 जेवढी ट्रान्सफर होणार आहे तेवढीच हीट 3 to 2 असणार आहे. म्हणजे 1 पासून 2 पासून 1 पासून 2 पर्यंत जेवढी हीट ट्रान्सफर असणार आहे ती हीट ट्रान्सफर सेमच असणार आहे. फक्त इथं काय होणार आहे, ड्यू टू दॅट in between plate what will happen, surface resistance will be increases. Okay, and due to that surface resistance heat transfer rate will be reduces. Okay, so all of you write down, let us consider two parallel plates. Let us consider two parallel plates, 1 and 2. Let us consider two parallel plates, 1 and 2, of area capital A, of area capital A, in bracket A1 is equal to A2 is equal to A. म्हणजे ज्या काय आपण दोन प्लेट कन्सिडर केलेल्या त्या दोन्ही प्लेटचा एरिया काय असणार आहे, सरफेस एरिया सेम असणार आहे. ओके, एरिया ए ॲट टेम्परेचर T1 and T2 respectively, T1 and T2 respectively, T1 and T2 respectively, T1 and T2 respectively, full stop, with a radiation shield placed between, with a radiation shield placed between them, with a radiation shield placed between them, radiation shield placed between them, placed between them, म्हणजे त्या दोन्ही प्लेटच्या मध्ये एक radiation shield ची प्लेट प्लेस केलेली आहे. So this is the information regarding that diagram. So all of you draw this diagram. Two plates are there, plate number 1 and plate number 2. In between these two plates there is a one radiation shield. Okay, so plate number 1, inside plate of 1, that is emissivity is epsilon 1, then radiation shield having both side emissivity is epsilon 3, and plate number 2, inside surface is having emissivity is epsilon 2. Okay, so heat transfer from plate 1 to 3, that is Q13, that is net, and then heat transfer from the plate number 3 to 2, that is Q32 net. So in that direction of arrow is given, that is direction of heat transfer is given, and T1 is greater than T2 means first plate having temperature is T1, second plate having temperature is T2. So T1 is greater than T2. So all of you draw this diagram. Okay, over. Anyone reply in the chat box? Diagram is over. Okay, diagram is over. Anyone reply in the chat box? Shall I proceed? Anyone? Anyone in the chat box? Okay. So next, yes sir. Next slide. Okay. So already we have derived the equation when two plates are there and heat exchanges takes place between the two plates. So for that we have deriving the equation. So all of you write down with no radiation shield. ज्यावेळेला radiation shield नसणार आहे दोन प्लेटच्या मध्ये त्यावेळेस आपण इक्वेशन ऑलरेडी डिराईव्ह केलेलं आहे. सो ऑल ऑफ यू राईट डाऊन दॅट इक्वेशन विथ नो radiation shields when with no radiation shields the net heat exchange between with no shields the net heat exchange between the net heat exchange between the parallel plates is given by the net heat exchange between the parallel plates is given by the parallel plates is given by the parallel plates is given by. So write down that equation Q12 net is equal to ज्यावेळेला radiation shield नसणार आहे मध्ये त्यावेळेला जी काही heat exchange होणार आहे दोन प्लेटच्या मध्ये. So what is the net heat transfer between that two plates? We have derived that equation. So all of you write down that equation Q12 net is equal to Q12 net is equal to A sigma T1 raised to 4 minus T2 raised to 4 T1 raised to 4 minus T2 raised to 4 T1 raised to 4 minus T2 raised to 4 divided by 1 upon epsilon 1 1 upon epsilon 1 plus 1 upon epsilon 2 minus 1 1 upon epsilon 1 plus 1 upon epsilon 2 minus 1. This is the equation number 1. This is the equation number 1. ओके. ज्यावेळेला रॅडिएशन शिल्ड हे दोन प्लेटच्या मध्ये नसणार आहे त्यावेळेस जी काही हीट एक्सचेंज होणार आहे दोन प्लेट मध्ये so that is what is the net heat transfer for that particular two plates. So that equation already we have derived, and what is that equation? Q12 net is equal to A sigma into bracket T1 raised to 4 minus T2 raised to 4 divided by 1 upon epsilon 1 plus 1 upon epsilon 2 minus 1, and this is the equation number 1. Okay, then next line write down if the emissivity of the radiation shield is epsilon 3. आता आपण जे काय radiation shield ची जी काय प्लेट असणार आहे त्या दोन प्लेटच्या मध्ये जी काय आपण पुट केलेली आहे त्याची इमिसिव्हिटी काय घेतलेली आहे दोन्ही सरफेस साठी आपण epsilon 3 घेतलेली आहे. सो दॅट वी हॅव टू राईट डाऊन if the emissivity of the radiation shield if the emissivity of the radiation shield is epsilon 3 if the emissivity of the radiation shield is epsilon 3 comma we can use this equation to find we can use this equation to find we can use this equation to find heat exchange between we can use this equation to find heat exchange between surfaces, heat exchange between surfaces 1 comma 3 and 3 comma 2. Okay, we can use this equation to find heat exchange between surfaces 1 comma 3 and 3 comma t 3 comma 2. ओके, म्हणजे हीट ट्रान्सफर जी होणार आहे ती कशा कशामधून होणार आहे, फर्स्ट सरफेस टू दी थर्ड surface and then third surface to the second surface. So for that there is a need of emissivity of the third surface, that is epsilon 3. Okay, so now we have to consider the first case. Heat transfer takes place from the surface 1 to the inside surface of the surface 3. डायग्राम कडे बघितलं तर तुम्हाला कळेल, डायग्राम मध्ये काय केलेलं आहे, बाहेरचा जो सरफेस असणार आहे तो इन्सुलेटेड असणार आहे. पहिली जी प्लेट आहे त्याच्या आतला सरफेस कडून हीट कुठे ट्रान्सफर होणार आहे, तिसऱ्या प्लेटच्या लेफ्ट हँड साइडला. ओके, सो फॉर दॅट वी हॅव टू राईट डाउन द इक्वेशन. सो ऑल ऑफ यू राईट डाउन Q13 surface 1 to surface 3, Q13 net, Q13 net is equal to, so what is the change in that equation? So in the first equation, for the if there is a no radiation shield is there, so for that case we have written the equation. So at the denominator what is that equation, or at the numerator a sigma T1 raised to 4 minus T2 raised to 4, म्हणजे T1 म्हणजे फर्स्ट प्लेटचं टेम्परेचर आणि T2 म्हणजे सेकंड प्लेटचं टेम्परेचर आहे. सो इन दिस केस वी हॅव टू टेक द टेम्परेचर ऑफ फर्स्ट प्लेट अँड थर्ड प्लेट, because heat transfer takes place from plate 1 to plate 3. So we have to consider the plate number 3. So what is the temperature of the plate number 3? That is T3. So what is the value, what is the equation at the numerator? That is a sigma into bracket T1 raised to 4 minus T3 raised to 4. And what is the equation at the denominator? So in equation number 1 we have taken the surface 1 and 2, so therefore 1 upon epsilon 1 plus 1 upon epsilon 2 minus 1, this is the equation. So for this case we have to take the equation as a 1 upon epsilon 1 plus 1 upon epsilon 3 minus 1, because in this case we have to consider in the plate number 3. So for the plate number 3 what is the emissivity? That is epsilon 3. So therefore we have to take the 1 upon epsilon 1 plus 1 upon epsilon 3 minus 1, and this is the equation number 2. समजले का बघा, प्लेट 1 आणि 3 आहे. सो फॉर दॅट वी हॅव टू राईट डाउन द इक्वेशन नेट हीट ट्रान्सफर. Okay, and similarly we have to consider now plate number 3 and 2. So in these two plates heat exchanges takes place. So now we have to write down the equation for the plate number 3 and 2. Okay, so similarly equation 1 and 2 we have to write down the equation for the plate number 3 and 2. Okay, so and Q3 to 32 net is equal to heat transfer in between plate number 3 and 2. Net heat transfer is equal to a sigma 3 to 2 आहे म्हणजे T3 raised to 4 minus T2 raised to 4. Okay, so I have to change the according to plates are there. So a sigma T3 raised to 4 minus T2 raised to 4 divided by, so earlier cases plate number 1 is there, so I have taking the 1 upon epsilon 1. So but in this case we have taking the plate number 3, so that is 1 upon epsilon 3 plus 1 upon epsilon 2 minus 1, and this is the equation number 3, and this is the equation number 3. Okay, so in the similar manner we have written the equation for the heat exchange between plate 1 and 3 and plate 3 and 2. Okay, so now give the numbering as equation number 3, equation number 3. Okay, आता मी मगाशी सांगितलं तुम्हाला जी काही आपण दोन प्लेटच्या मध्ये एक रॅडिएशन शील्ड अटॅच केलेलं आहे, पण ह्याचा अर्थ तुमच्या सिस्टीम मधली हीट रिमूव्ह केली जाणार नाही किंवा डिलिव्हर केली जाणार नाही. सिस्टीम मधली हीट सेम असणार आहे, म्हणजे हीट ट्रान्सफर जी 1 to 3 असणार आहे तेवढीच हीट ट्रान्सफर 3 to 2 असणार आहे, आणि तेवढीच हीट ट्रान्सफर तुमची 1 to 2 पण असणार आहे. सो देअरफॉर ऑल ऑफ यू राईट डाउन, सिन्स द रॅडिएशन डज नॉट डिलिव्हर, since the radiation does not deliver or remove heat from the system, since the radiation does not deliver, since the radiation does not deliver or remove heat from the system, or remove heat from the system, or remove heat from the system, or now at steady state, now at steady state temperature T3. समजले, एक स्टेज अशी येणार आहे की तुमची जी काही हीट ट्रान्सफर होणार आहे जी काय तुम्ही रेडिएशन शिल्ड मध्ये पुट केलेलं आहे ते इक्विलिब्रियम स्टेजला येणार आहे, म्हणजे 1 to 2 तुमची हीट ट्रान्सफर होणारच आहे. शिल्डचं जे टेम्परेचर असणार आहे ते काय होणार आहे, T3 कंटिन्युअस राहणार आहे. ओके, सो देअर फोर steady state will be arises. Okay, so for that, since the radiation does not deliver or remove heat from the system, or now now at steady state temperature T3 is there. Steady state येणार म्हणजे टेम्परेचर T3 तुमचं कॉन्स्टंट राहणार आहे. सो देअरफॉर Q1 to 3. Okay, so I have to write down the equation Q13 net is equal to Q322 net. So write down that equation, equate that two equation, A sigma T1 raised to 4 minus T3 raised to 4 divided by 1 upon epsilon 1 plus 1 upon epsilon 3 minus 1 is equal to A sigma T3 raised to 4 minus T2 raised to 4 divided by 1 upon epsilon 3 plus 1 upon epsilon 2 minus 1. Okay, equate that two equations. Okay, now at this steady state, these two values are same values are there. So for that we have to write down the equation or equate these two equation. Okay, write down these two equation, A sigma T1 raised to 4 minus T3 raised to 4 divided by 1 upon epsilon 1 plus 1 upon epsilon 3 minus 1 is equal to A sigma T3 raised to 4 minus T2 raised to 4 divided by 1 upon epsilon 3 plus 1 upon epsilon 2 minus 1. Okay, next slide. Okay, so now we have to consider the 1 upon epsilon 1 plus 1 upon epsilon 3 minus 1 as a x. Okay, so let we have to consider 1 upon epsilon 1 upon epsilon 1 plus 1 upon epsilon 3 plus 1 upon epsilon 3 minus 1 is equal to x, is equal to x. And then second term, that is 1 upon epsilon 3, 1 upon epsilon 3 plus 1 upon epsilon 2 minus 1 is equal to y. Okay, so all of you have to consider, instead of 1 upon epsilon 1 plus 1 upon epsilon 3 minus 1 as a x, and 1 upon epsilon 3 plus 1 upon epsilon 2 minus 1 is equal to y. Okay, so now in the equation, earlier equation, जे आपण इक्वेशन इक्वेट केलेलं आहे Q13 net is equal to Q32 net, ते जे इक्वेशन आहे, in that equation we have to put that values, instead of 1 upon epsilon 1 plus 1 upon epsilon 3 minus 1, instead of that we have to put the x, and 1 upon epsilon 3 plus 1 upon epsilon 2 minus 1, instead of that we have to put the y. So a sigma will be cancelled, so remaining equation we have to write down. So what is the remaining equation? That is T1 raised to 4 minus T3 raised to 4. Equate kara value and write down that equation. Okay, put that values and write down the equation. So what is the equation becomes? T1 raised to 4 minus T3 raised to 4 divided by x is equal to T3 raised to 4 minus T2 raised to 4 divided by y, because a sigma will be cancelled to both sides. Okay, so then simplify this equation. You have to do the simplification on this equation. So the now equation becomes T1 raised to 4 divided by x, T1 raised to 4 divided by x minus T1 raised to 4 divided by x minus T3 raised to 4 divided by x is equal to T3 raised to 4 divided by y minus T2 raised to 4 T2 raised to 4 divided by y. Okay. Then we have to take the T1, T2 terms at the left hand side and T3, T4 and T3 terms at the right hand side. So what is the equation becomes? Write down the equations. T1 raised to 4 divided by x plus T2 raised to 4 divided by y. T2 raised to 4 divided by y is equal to T1 raised to 4 divided by x plus T2 raised to 4 divided by y is equal to T3 raised to 4 divided by y plus T3 raised to 4 divided by x. T3 raised to 4 divided by x. Okay. T3 raised to 4 divided by y plus T3 raised to 4 divided by x. Okay. Take LCM on the both sides. So what is the LCM at the left hand side? That is x by x into y. So take the cross multiplication. Then we get the equation as a y t1 raised to 4 plus x t2 raised to 4 divided by xy is equal to, take the LCM at the right hand side and we have to take the t3 raised to 4 as a common. So what is the remaining term in that equation? That is x plus y divided by xy. X plus y divided by xy. Okay. So we get the equation as a y t1 raised to 4 plus x t2 raised to 4 divided by x into y is equal to t3 raised to 4 t3 raised to 4 into bracket x plus y divided by xy bracket complete. Okay. Then xy is at the both sides, so xy will be cancelled. As our next slide. Okay. So xy will be cancelled. So what is the remaining equation? Y t1 raised to 4 y t1 raised to 4 plus x t2 raised to 4 y t1 raised to 4 plus x t2 raised to 4 is equal to t3 raised to 4 into bracket x plus y t3 raised to 4 into bracket x plus y. So from this equation we have to write down the equation for the t3 raised to 4. Okay. So all of you now you have to make the t3 raised to 4 as a subject and you have to write down the value for that. So t3 raised to 4 is equal to, now I have to write down the equation for t3 raised to 4 is equal to y t1 raised to 4 y t1 raised to 4 plus x t2 raised to 4 y t1 raised to 4 plus x t2 raised to 4 divided by x plus y divided by x plus y. Okay, divided by x plus y. So already we have equation as a q13 net. Okay, so in that equation number 2 बघा, equation number 2 काय आपलं, what is the equation number 2? That is q13 net is equal to a sigma into bracket t1 raised to 4 minus t3 raised to 4 divided by 1 upon epsilon 1 plus 1 upon epsilon 3 minus 1. पण 1 upon epsilon 1 plus 1 upon epsilon 3 minus 1 च्या जागी आपण काय केलेलं आहे, x पुट केलेलं. So a sigma okay into bracket t1 to 4 minus t3 raised to 4, t1 to the same minus t3 raised to 4. So already we have calculated the value of t3 raised to 4. So we have to put that value into this equation. Okay. So all of you write down. Therefore, q13 is equal to heat exchange between surface number 1 and surface number 3. So write down the equation q13. So already we have written the equation number 2. So in that equation we have to put the value of 1 upon epsilon 1 plus 1 upon epsilon 3 minus 1. Instead of that we have to put the x and then we have to put the t3 raised to 4 as a y t1 raised to 4 plus x t2 raised to 4 divided by x plus y. Okay, so therefore all of you write down Q13 is equal to Q13 is equal to A sigma upon X, A sigma upon X into bracket T1 raised to 4, T1 raised to 4 minus y T1 raised to 4 plus X T2 raised to 4 divided by X plus Y, divided by X plus Y, divided by X plus Y. All of you put that values. Now we have to simplify that equation, whatever the equation which is present inside the bracket. We have to simplify that equation. So take the LCM. So LCM is X plus Y. Then we have to take the cross multiplication. So X T1 raised to 4 plus Y T1 raised to 4 minus Y T1 raised to 4 minus X T2 raised to 4. Okay. So we have to do the simplification inside the bracket and we get the equation. So all of you write down that equation. Do the simplification and write down the equation. Okay, so y t1 raised to 4 minus y t1 raised to 4, that will be cancelled. Positive or plus y t1 raised to 4 minus y t1 raised to 4 is there. So plus minus that term will be cancelled. So what is the remaining equation? Q13 is equal to a sigma. Okay, and after that x t1 raised to 4 and minus x t2 raised to 4 is there. So from that we have taken the x as a common. So at the denominator is there x and at the numerator is also there is x. So x will be cancelled. So what is the remaining term at the numerator? That is t1 raised to 4 minus t2 raised to 4 divided by x plus y. So all of you write down this equation. q13 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 is equal to a sigma into bracket t1 raised to 4 minus t2 raised to 4, t1 raised to 4 minus t2 raised to 4 divided by x plus y, divided by x plus y. Okay, so now we have to put the value of x and y into this equation. So instead of x, what is the value? That is 1 upon epsilon 1 plus 1 upon epsilon 3 minus 1. And what is the value of y? That is 1 upon epsilon 3 plus 1 upon epsilon 2 minus 1. So instead of x and y, we have to put the values into this equation. Then equation becomes, okay, next slide. Okay, so all of you write down, instead of x, we have to put the value of 1 upon epsilon 1 plus 1 upon epsilon 3 minus 1. And what is the value of y? That is 1 upon epsilon 3 plus 1 upon epsilon 2 minus 1. So put that value. So equation becomes q13 is equal to a sigma into bracket t1 raised to 4 minus t2 raised to 4 bracket complete divided by x plus y. So x value is 1 upon epsilon 1 plus 1 upon epsilon 3 minus 1 plus 1 upon epsilon 3 plus 1 upon epsilon 2 minus 1. Okay, so 1 upon epsilon 3, 1 upon epsilon 3 is 2 times is there. So remaining values we have to write down the in the one equation. So what is that equation? Q13 is equal to a sigma t1 raised to 4 minus t2 raised to 4 divided by, so we have to take the sum values into first bracket, that is 1 upon epsilon 1 plus 1 upon epsilon 2 minus 1, and then 1 upon epsilon 3 is 2 times is there, so 2 upon epsilon 3 minus 1 is there. Okay, so this q13 is nothing but q3 to 2 and q1 to 2. समजले बघा, जेवढी हीट ट्रान्सफर 1 to 3 असणार आहे तेवढीच हीट 3 to 2 असणार आहे आणि तेवढीच हीट 1 to 2 असणार आहे. सो देअरफॉर q13 चं जे इक्वेशन आहे that is equal to q3 to 2 and that is equal to q1 to 2 also is there. Okay, so this is the equation when there is a radiation shield is there. समजतंय बघा, ज्यावेळेला रॅडिएशन शिल्ड नव्हतं त्यावेळेचं इक्वेशन काय होतं, ह्या प्लस साइन नंतरचं जे काही ब्रॅकेटमध्ये छोटंसं इक्वेशन आहे 2/(epsilon3 - 1) ही टर्म इथे एक्स्ट्रा आलेली आहे. समजते बघा, ही टर्म एक्स्ट्रा आल्यामुळे काय होणार आहे, तुमचं रेट ऑफ हीट ट्रान्सफर कमी होणार आहे. ओके, इफ देर आर टू प्लेट्स आर ओनली देअर, सो दिस 2/(epsilon3 - 1) this term is not there. Okay, if denominator is increases means automatically net heat transfer will be decreases. So if we are using the radiation shield, automatically this Q13 value will be reduces. Okay, so that is resistance is increases. म्हणजे ऑलरेडी जो रेजिस्टन्स होता, ज्या रेडिएशन शिल्ड नव्हतं त्यावेळेचा रेजिस्टन्स काय होता, 1/(epsilon1 + 1/(epsilon2 - 1) एवढीच टर्म होती. तिथे ऍडिशनल टर्म कुठले आलेले, 2/(σ3 - 1). So that is resistance is increased by 2/(σ3 - 1). So therefore Q13 decreases. So after that we have to put that equation in the or mark the important that equation as a Q13. म्हणजे हे Q13 जे इक्वेशन आहे हे ट्रान्सफर विथ शिल्ड आहे. समजते बघा, Q13 दिस इज द इक्वेशन फॉर द विथ शिल्ड. सो व्हॉट इज that equation? A sigma T1⁴ - T2⁴ divided by 1/(epsilon1 + 1/(epsilon2 - 1), okay, plus 2/(σ3 - 1). Okay, so this is the equation when there is a radiation shield is there. ज्यावेळेला radiation shield नव्हतं त्यावेळेला इथं फक्त कुठले ऍडिशनल टर्म आले तर 2/(σ3 - 1). this term is additional term is there. So therefore after that equation we have to write down that is resistance increases by, रेजिस्टन्स कुठल्या व्हॅल्यू इन्क्रीज झाला, कितीने इन्क्रीज झालेला आहे, तर ती व्हॅल्यू जी आहे ती ब्रॅकेट मधली आहे 2/(σ3 - 1). सो राईट डाउन दॅट इज resistance increases by 2/(σ3 sorry 2/(epsilon3 - 1), 2/(epsilon3 - 1), 2/(epsilon3 - 1). therefore Q123 is decreases. रेजिस्टन्स म्हणजे डिनॉमिनेटर वाढला तर ऑटोमॅटिकली हीट ट्रान्सफर रेट कमी होणार आहे. सो therefore Q13 decreases. Q13 decreases. Okay, so remaining part we have to take in the next lecture. So all of you put your roll numbers in the chat box. Okay, so after 2 minutes, yes sir, we have to stop the recording. All of you put immediately your roll numbers in the chat box so that I will take your presenting.